Good evening, all of you. Welcome, you guys. Welcome you all. Welcome you all. So, how you are doing? Everybody, कैसे हो सभी लोग? I hope all of you are doing great. Welcome to Unacademy. So, all of you do join the session fastly. We are going to have a great session today. And so, what are the doubts you have? All of you do post your doubts and let's discuss your doubts. Now, before this, we have a great announcement. There is a chance to get 100% of scholarship, and so you can able to save the best buy. So that is, you can able to save the more than 20% discount. More than 20% discount is available. So for the plus as well as the iconic subscriptions, and to enroll for it, you can use the code of B V Reddy to avail the great discounts. Use the code of B V Reddy and you can enjoy the more discounts. Use the code of B V Reddy. Right. This offer, which is applicable for all the branches, and the code B V Reddy, which is a universal code, this code is applicable for all type of Unacademy subscriptions. Right. Next, and here the new batches we are starting. You can see here, and this is and Subha Edisa is starting the new subject, that is discrete math is starting at the 6 a.m. morning. And you can find the top educators of Unacademy team for CSE, and you can see now here the top educators. The Subha Edisa is starting the discrete mathematics, and you can see now you can plan the gate for, as you know, new subject has been launched, that is a data structures and artificial intelligence. Right. So you can plan this subscription, you can be able to plan it. So here, so you can avail the top educators recording lectures as well as the video lectures are available. Right. Next, you can plan the daily scholarship test. Yes, I'm very good. Yeah, Shashank, kaise ho sir? I hope all of you are doing great. Now you can plan this Unacademy subscription with a no cost EMI without paying any additional charges. You can able to plan it. So students, what are the doubts you have? All of you post your doubts and we will discuss each and every doubt. I'll discuss here. Now, yes, first of all, is this display is clear to all of you? Tell me. So is this thing clear to everybody? Are you able to see this thing properly? Tell me first of all. Yes. So shall we start our discussions now, all of you, everybody? And let's start discussions. And let us start our discussions. चलिए. Now look at now here what they given. First of all, you tell me now here. Yes, now this is what gate, you tell me now. This is a NOR gate. All these are the NOR gates. All these are the NOR gates are given, and you can see now here. And see here, this inputs for this is x1, this is a x2, and here they has taken the output y. So अगर आपने ध्यान से देखा तो ये तो बर्फी आपको दिख रहा कि नहीं बोल? अगर आपने ध्यान से देखा तो इधर आपको बर्फी दिख रहा कि नहीं बोल? यस, ये बर्फी आपको दिख रहा ना? हियर एंड हियर, ये तो हमारा बर्फी है ना? टेल मी नाउ, कौन सा बर्फी है? So what is barfi, you tell me now here? NAND वाला, NOR वाला? So you see this thing, एक कौन सा बर्फी है? काजू वाला और बादाम वाला here. So here, so this is the NOR बर्फी. NOR बर्फी बोले तो काजू और बादाम हमने नाम दिया ना. So this is a NOR. So means what we can say, tell me now, output Y, which will becomes what, tell me now, XR will come or XNOR will come? XR will come or XNOR will come? Which is XNOR will come na? All of you बोलिए, not तो here XNOR आएगा. So this is my Y is equal to X1 XNOR with X2. So from this Y, which could be given as X1 XR with X2 whole bar, isn't it? So कौन सा ऑप्शन टेल मी नाउ हियर? इसके लिए ऑप्शन डी है ना. So this option D. The next one. So here is a common data question. Second one, tell me now here. The D flip flop are initialized to 0 0 after one clock pulse. What is the output value? Right. Initially this value given as what, tell me now, 0, and all these values are zeros. And you can see now here, then see this thing here, after one clock pulse क्या होने वाला, you need to see it. Look at now here, after one clock pulse, this is the 0 and 0, this is x1 value 0 and this value 0 now here, input 0, isn't it? Now you can see now here, this output, this is output, this is output, is a input आएगा. नेक्स्ट इधर आउटपुट देखो इधर. सो अगर आपने ध्यान से देखा तो दिस वैल्यू 0 आई, ये वैल्यू भी 0 आई, isn't it? Now you tell me now y क्या आएगा, tell me now here. So y is what now here, both are same ना, 0 XNOR with 0. So क्या आएगा, both are equal case, आउटपुट 1 बनेगा. क्या बनेगा, आउटपुट तो 1 आएगा. So y वैल्यू 1, ये था इनपुट. now tell me, this is the input. So means after one clock pulse क्या होने वाला, you tell me. After one clock pulse क्या होने वाला, you tell me. So A1, yes, the Q1, yes, that is Q1, Q2 and Q3 क्या होगा, tell me. After one clock pulse Q1 0 बनेगा, Q2 1 होगा and Q3 0 होगा. Check it all of you. Done. चलो नेक्स्ट प्रॉब्लम. सो कौन सा ऑप्शन, टेल मी इधर, ऑप्शन बी. Next one. The 8-bit left shift register and the D flip-flop shown in figure below is synchronized with the same clock. The D flip-flop is initially cleared. Now they are asking the circuit will behave as what, you tell me now. They are saying. Now they are saying the circuit will behave as what? Tell me now here. Initially, left shift register shown in figure single the same clock. Now they are asking what should be this thing here. This is B7, B6, B5 like this. Yeah, सबसे पहले देखो इधर. Initially, this is output of the D flip flop is given as a 0. Now you tell me now here, this B7, here B7 आएगा. And this B7 इधर भी आएगा. This is B7 आएगा इधर भी. B7 इधर भी आएगा. Okay. Now you can tell me now here. So what is the output of this, you tell me. 0 XR. So this is B7 only na XR, and this B7 इधर होगा. After one clock pulse क्या होने वाला, you tell me. आफ्टर एक क्लॉक पल्स अप्लाई करने के बाद क्या होगा, यू टेल मी नाउ हियर. ये B7 डिसअपीयर होगा ए प्लेस में, इधर B6 आएगा, इधर एक शिफ्ट होगा कि नहीं बोलो. एंड दिस इज B5 होगा, दिस इज B4 एंड दिस इज B3 एंड B2 B1 एंड दिस इज B0. B7 इधर एंटर होगा ना. टेल मी रजिस्टर्स कैसा काम करेगा, वेन एवर देयर इज अ क्लॉक ओनली देन ओनली विल काम करेगा. एंड यू टेल मी नाउ हियर, ये वाला ए B7 इधर आएगा, ए B7 आफ्टर वन क्लॉक पर दिस डी फ्लिप फ्लॉप ना, सो B7 इधर आएगा. ओके नहीं, दिस इज आफ्टर वन क्लॉक पल्स. नेक्स्ट सेकेंड क्लॉक पल्स अप्लाई करने के टाइम में क्या होने वाला, अभी आप देख लो इधर. दिस इज द सिचुएशन. आफ्टर द नेक्स्ट क्लॉक पल्स क्या होगा, यू टेल मी नाउ हियर. दिस इज B6 इधर वेट करेगा, दिस B6 बट दिस इज डायरेक्ट कनेक्शन है, B6 इधर आएगा. नाउ टेल मी व्हाट विल कम नाउ हियर. फर्दर दिस इज अ XR गेट. XR गेट लॉजिक गेट्स के लिए कोई क्लॉक नहीं चाहिए. SR नो. सो दिस इज ओनली द फ्लिप फ्लॉप्स एंड रजिस्टर के लिए क्लॉक चाहिए. सो दिस आउटपुट विल बिकम्स व्हाट, टेल मी. B7 XR विथ B6 होगा ना, टेल मी. एंड दिस B7 XR विथ B6 इधर वेट करेगा. यस, कब ये अंदर जाएगा, जब भी आपने एक क्लॉक अप्लाई किया. सो व्हेन एवर इफ यू अप्लाई क्लॉक सिग्नल, तभी ये अंदर घुसेगा. Isn't it? Now you tell me now second clock. After second clock क्या होगा, you tell me. I think you fellows might be understand the sequence. हाँ ना बोल. You fellows might be understand the sequence, isn't it? Now you can tell me now here. After this, so this is a first clock pulse. Initially we have this 0th clock pulse, B7 B6 B5 B4 and this is B3 B2 B1 and B0. This is the 0th clock pulse. Next first clock pulse क्या होगा, you tell me. At the first clock pulse क्या होगा, tell me इधर. After first clock pulse क्या होने वाला इधर. So this B6 इधर आएगा, this is B5 and ये लेफ्ट शिफ्ट होगा ना, B4 and this is B3 and B2 B1 and this is B0 and इधर B7 आएगा ना after one clock pulse. Next now second clock pulse क्या होगा, tell me इधर. and B5 इधर शिफ्ट होगा, B5 इधर आएगा and this is B4 and this is B3 B2 B1 B0 and B7. Now tell me after this इधर क्या आएगा, tell me now here. B7 XR with B6 आएगा, tell me. हाँ कि नहीं बोल. You don't understand this pattern. And if you apply third clock pulse क्या होगा, tell me. third clock pulse क्या होगा, and इधर B4 आएगा, next B3, next B2 B1 B0 B7 and this is B7 XR with B6. This is एक ही term and thereafter tell me क्या होगा इधर. B5 XR with B6 होगा ना? B6 XR to B5. Next, now fourth clock. So क्या होगा? Tell me now here. B3 and this is B2, B1, B0, B7 and this is what will get? Tell me now here. B7 XR with B6 and what is this thing here? B6 XR with B5 and B5 XR with B4. ऐसा बनेगा कि नहीं बोल? Next, if we apply fifth clock, क्या होगा? Tell me now here. B2, B1, B0 and B7 XR with B6 and B6 XR with B5 XR with B4 XR with B3. Next, sixth clock pulse. Tell me क्या होगा? Now this is B1 and this is B0, B7 and B7 XR with B6 and B6 XR with B5. ऐसा कंटिन्यू होगा ना? टेल मी. And B5 XR with B4 XR with B3. Next, what else? Tell me now. B3 XR with B2. Now can you tell me now seventh clock pulse में क्या होगा? In the seventh clock pulse क्या होगा? Tell me. So this is B0, B7, B6 XR with B5 and B5 XR with B4 and B4 XR with B3 and B3 XR with B2 and B2 XR with B1 and B1 XR with B2 previously क्या? B2. Yes, that's all now. How many? 1 2 3 4 5 6 7. What is missing here? B3 B2 B1 6 1 2 3 4. One more term is there na? Anything we have missed now here? B0 will come here. B0 B7 B0 B7. Okay, we have missed this thing. Right, this is what? Tell me now here. B7 XR with B6. Next, eighth clock pulse, finally B7 and thereafter what shall be now here? B7 XR with B6 and next what will get now here? B6 XR with B5 and B5 XR with B4 XR with B3. Next, B3 XR with B2 and B2 XR with B1. ऐसा बनेगा? Tell me. This is the scenario will happens. Now after 8 clock pulse, this is the scenario. Can you tell me now what we can say this is? Can you tell me now what we can call this is now here? Kaun sa sequence you see this thing? This is nothing but the conversion from weight to weight. Now tell me, the binary to gray code conversion, isn't it? If we have this as a binary numbers are given, tell me now, let us say binary numbers they given as a binary numbers they given as a B7, B6, B5, B4, B3, B2, B1 and B0. This is the binary sequence is given, consider. Now tell me now what we can do, how we can do the gray code sequence, you tell me. Gray code के लिए, so this MSB bit as it is will copy it. Now tell me B7 we should to copy. Then after what we need to do here, we need to take the XOR between these two. That is what I can say, B7 XOR with B6. Next XOR between these two, B6 XOR with B5. Next XOR between these two, B5 XOR with B4. Next XOR between these two, B4 XOR with B3. Next XOR between these two, B3 XOR with B2 and these two, and B2 XOR with B1, and this is finally B1 XOR with B0. ऐसा आएगा ना बोल. Now you can see this thing here. Now can you tell me now this is what the sequence you can observe now here. So this one and this one दोनों same ना. This is the gray code sequence ना. This is the gray code. So what we did, you would see this thing carefully. We have converted this as binary to gray code. We have converted, this is nothing but what we can say here, binary to gray code conversion. Done. So this is the manner we need to do it. Chalo, all of you. Next problem. This is one good problem, बहुत बढ़िया problem. Yes. Now you tell me now, you try करो this one. What will come? The 8-bit left shift register and the D flip-flop shown in figure. Yes, tell me now here. Is synchronized to the same clock. The D flip-flop is clear. Initially, they given the register content is B7. After 4 clock pulses, they ask him to find the content. What will be the content here? So B7 is given. B, how much the B value, tell me now here, which is nothing but 11, 1, 1 initially. And 7 means what, tell me, 0, 1, 1, 1. This is the initial content, right? Now you can see now first clock pulse kya hoga. So this is the pattern we have observed now. So this first clock pulse, this thing, and second clock pulse, this thing, third clock pulse and fourth clock pulse. This is the scenario, you tell me. After 4 clock pulse, this is the scenario, isn't it? Now you can see this thing here. First clock pulse kya hoga, tell me now there. So here initially this is first clock, initially 0th clock. So tell me now here, this is 1, 0, 1, 1 and 0, 1, 1, 1. Right. Next, tell me now second clock pulse kya, first clock pulse, second, third, fourth. Tell me now first clock pulse kya hoga, tell me now there. This B7 will go there. So this is 0, 1, 1 and 0. and this is 1 1 1 0 banega. Tell me all of you. Hmm? So this is 1 not 0 1 na? This is 1 banega, right? And then thereafter what you tell me, next clock pulse what happens now? 1, next clock pulse 1 1 1, why 1 0 na? 0, this is 1, right? 1 1 1, this last bit which is the XR between 0 and 1, XR between this and this. Now tell me what I will get. 1 will come. Next tell me third clock pulse क्या होगा, tell me. 1 left shift now here, 0 1 1, and this is what, tell me now here, 1 1 1. Now XR is a 0, isn't it? Next tell me the next clock pulse here क्या होगा, fourth clock pulse. So this is 0 1 1 1. Next what, tell me, 1 1 0, XR between 1 and 0 which is 1. All of you tell me this thing. Check this thing here. Got it, all of you? Shall I repeat it now? Tell me. किसी को doubt हुआ तो shall I repeat this thing? Shall I repeat this thing? Hmm? Tell me now here. Shall I repeat this thing? If you want, I will repeat this thing again for you. Oh. Understood this pattern here? You can see the same pattern. Fourth now here. What we can see here? This is, and look at now here. This is exactly this one. This thing will come. B7 XR with a B6. You can see now B7 XR with a B6. You can see now here. This is the thing will come now. You can observe here after fourth clock pulse. After fourth clock pulse, and we'll get this is the pattern will come. Isn't it? All of you. This is the thing will come now. You can see. This is the situation after fourth clock pulse. Now what is the data they given? You can see now. This is the data. This is the initial data we have. Now you can tell me now here this is, and look at now here, this is the data which is nothing but what, tell me, B7, this is the B6, B5, this is B4, B3, B2, B1, B0. After 4 clock pulses, you can tell me now here. So this is B3 value 0, this is 1 1 1, and B7 is 1. B7 XR with B6, XR between these two which will be 1. B6 XR with B5, XR between these two which is equal to what, tell me here, we'll get this as 1. B5, B4, these two, which will get it as 0. I think somewhere we have did a mistake here. Yeah. इसने कुछ गलत किया इधर. Look at now here, this is, now I can convert this thing into what? Tell me now here, convert this into a binary to hexadecimal. Now tell me now here, this is, we can convert it now. This value is how much now? 7. And how much this value? This is 14, isn't it? So this means E. So what's the answer? Tell me now. 7E. Done. Chalo, next problem. That is a very good problem. All of you do practice once again. Enter the next one. In the given counter, each flip-flop has a propagation delay of 8 nanoseconds. The worst case delay time from a clock pulse to arrive the counter. So this is what type of counter, you tell me now here? It is a asynchronous counter. Can you tell me the time period which is given as n into TPD? N into TPD. So how many flip-flops are there? 3 flip-flops. So means what I can say now? 3 into TPD. Each delay given as 8 nanoseconds. So 8 into 10 power minus 9. Yes, this is a time period. So how much this value? Tell me now here. This is 24 nanoseconds. Right. Yes, the delay must be always. Yes, now here. Yes, then from this we can say the delay which is equal to what I can say, tell me, which is equal to 24 nanoseconds. Delay must be, so that when we should give the next clock pulse, time period must be always greater than the delay. So after all the flip-flops are giving the output, then we should apply the next clock pulse. We need to wait until all the flip-flop has to respond. Respond होने तक हम wait करना पड़ेगा. Next problem. If counter starts at 0, 0, 0, what will be the count after 13 clock pulses? Okay. They are asking after 13 clock pulses, they are asking. Now first of all, you can see now this is what type of counter? Synchronous, yeah, asynchronous, you have to see first of all. This is what type of counter now? First tell me now. Asynchronous counter. अलग अलग क्लॉक ना एसिंक्रोनस. एसिंक्रोनस में केवल 2 सीक्वेंसेस पॉसिबल, either up sequence या down sequence. Now tell me here, what is the counter? You tell me now, up counter या down counter. You can see now here, clock is what will be? External clock is given to this flip-flop. So that flip-flop is a LSB. The other one is what I can say, this is MSB. The other flip-flop is a MSB. Okay, so that means the sequence what we need to see, tell me now here, that is Q2, Q1, and this is my Q0. And this is what counter, you tell me now here. So clock is what, tell me now here, this clock is going. So this is Q and this is given as negative edge trigger. So this is minus Q. अभी इधर किस में आए, दुख में आए कि सुख में आए? ये तो अभी दुख में आए ना. ये दुख है तो दुख के बाद क्या आएगा? सुख आएगा. So mean this is what counter I can say? Up counter. So means this is a moderate up counter. So from this, what we can say now, 0th clock pulse. Initially, they given the 0th clock pulse. The state is given as 0, 0, 0. After 8th clock pulse, the state will repeat. Now tell me. So then at the 8th clock pulse, can you tell me the state of a counter? Same आएगा. 8 clock pulses, the output तो same आएगा. Okay. Now you can tell me now here 8th clock pulse. They are asking for 13 clock pulse. 8 means what of that? 9. We have a 10, 11, 12, 13th clock pulse we required. And so here now this is a up counter, next one is 001, and next one is 010, and next one is 011. This is 100, and this is what, tell me, 101. So at the 13th clock pulses, what the state will come, tell me? 101. Next one. In master slave JK flip flop, tell me what happened now here. Master slave flip flop, one is a positive level trigger, the other one is a negative level trigger. One is a positive level, the other one is a negative level trigger. And see this thing what they given. For the given sequential circuit, the next state equation for the flip-flops is given as. We need to find the next state equation we have to find here. And look at now carefully. This is what flip-flop now here. They are asking for the both flip-flop or only one flip-flop. Flip-flop A and B both we need to find. So you see this thing there, JK flip-flop. So can you tell me now JK flip-flop? So they given A given. So what is the characteristic equation of JK flip-flop? First of all you tell me Q plus, which is given as what, you tell me, JQ bar plus K bar into Q. First thing, JQ bar plus K bar into Q. And for the JA, tell me now JA what is given, you tell me. JA, yeah, here you can see now this is the NAND gate. Here what will come now here, this is B into X bar whole bar, and this again bar, so it will becomes what, tell me now here, BX bar only, right? And so what about the JA value here? This is XB bar, isn't it? And this is X bar into B, and these are given as a NAND gate is given. So क्या आएगा JA, tell me there, JA, which will come it as what, tell me now here. This is X bar into B into, this is X into B bar whole bar. So this is nothing but what will come now here, X bar B plus X, one second, this is what will come, you tell me now here, this is X plus B bar into X bar plus B, isn't it? Now we can apply T2, we can apply now. So from this what I will get, tell me now here, XB plus X bar into B bar. That means this is nothing but XB XNOR with B, X XNOR with B na. This is my correct only na. Okay, there is one more बात here. क्या हमने क्या किया दूसरा बार हमने मिस किया, NAND gate ना. So tell me now here, this is what we can say now, this is X bar B whole bar into X into B bar whole bar again whole bar. So this means which is a X bar B plus x b bar. So this means what I can say, x XR B. Now tell me, this is a x XR B. Find JA value. Next, whatever KA value, tell me that KA is equal to BX bar. KA is equal to what? Tell me, BX bar. Ayana. Now we need to find out this output equation we have to find. Now let's find out this output equation here. And we can say this equation, we will write it as a plus. We can write a plus, which is given as what? Tell me, j q bar. Yes, means what I can say, j means what? Tell me now here, x xr with what? Tell me, b. J q bar, q means what now here, a, plus k bar into q. K bar means what? Tell me here, this is b bar plus x. Q means what? Tell me now here, q means a. Okay, now let's simplify this equation here. What I will get here, this, which I can get it as, yeah, so this is a bar into x xr b plus plus what I am getting now here, this is a into b bar plus x. You can check this thing. And can you tell me this one here, this is exactly satisfying केवल this option में, isn't it? Next, so here we can say that this will be the options. This option it is satisfying now here. And if it is any other two options are there, we need to find the JB, KB also we need to do it that one. So you can see now what is the JB value here. This is the NOR gate now. So means what we will get, tell me now here, X bar A. Look at now here, JB. What is JB? Tell me now here, this is X bar plus A bar whole bar. So what I'll, both are same only. Fine. So this is what I'll get, tell me now, XA. We'll get it as what? Tell me now here, X into A will come. Now KB also same only now, which is nothing but XA. So tell me now here, this is A plus, which is given as J, that is A into X, and Q bar means what I can say, this is A bar. A bar plus K bar. K bar is what we can say now, this is X into A whole bar, and then Q means what? Tell me, A only. So this is A plus, which is given as A into A, which will become as a, okay, here this output is B. Sorry, this output they given as a B. Okay. So means we will take this as a B bar, and here this is a B. And this is only the YouTube class only. Yes, this is only in the YouTube only, it is not in the Plus. केवल YouTube में होगा this thing, this classes. Output they called it as B plus. So B plus, which is given as like this. Now tell me now what I will get now, B plus, which is given as, you can see now this is A B bar X plus, this is B into X bar plus A bar. This option A is satisfying, check it now. Right, good problem. Next one, the minimum number of D flip-flops needed to design a mod 258 counter. How many required now here? Minimum number of D flip-flops required. How many flip-flop required for the mod 258 flip-flop? Yes, 258 flip-flop means what I can say, mod 258. So if I use this thing as a 8 flip-flop, that is 2 power 8, which will come it as what, tell me, 256 only na. So 2 power 9, which is equal to 512. So this means these many flip-flops required, 9 flip-flops are required. Okay, next one. A JK flip-flop can be implemented by T flip-flops. This is the manner. Now they are asking which circuit can satisfy. Now the only thing is we can do verification method we can do here. Otherwise it is remembering the tables are very difficult, so better go for the verification method. One flip-flop can store only one bit only na. One flip-flop can store one bit of data only. Right. So we need to implement a JK flip-flop has to be implemented by using T flip-flop. Can you tell me now? I need the JK flip-flop. So JK flip-flop characteristic equation is what? Tell me now here. That is JQ bar plus K bar into Q. Now we need what you see this thing here. I have a T flip-flop is there. You can check this thing which equation will give the T flip-flops. Okay, now check the verification from the option say. First option, what the T value given, you tell me here. Here we have Q bar. So where T is equal to what here, tell me. Q se hua. So means what I can say now, this is JQ bar. This is what, tell me, JQ bar plus K into Q. JQ bar plus K into Q. Now this is a T flip-flop now here. What the T flip-flop characteristic equation? Which is given as what, tell me now here. T XR with Q. T XR with Q. So means what I can say now here. Q plus XR with Q. So what I will get to, tell me now here. That is T bar into Q plus T into Q bar. So what I will get to, tell me now, Q plus verification से करना पड़ेगा इधर. So T bar means इसका we can do it now. Simplifications करो. If you T bar means what we can say here. Here what I will get now here, J Q bar. So this is J bar plus Q into what I will get now here. This is K bar plus Q bar into Q plus. So what we'll get now here, this is JQ bar plus KQ into Q bar. Now let's simplify this equation. Carefully simplification करना पड़ेगा इधर. So what I may get here, this is Q plus, which is equal to, so if I do the T2, 1, 2, 3, 4, can you do the T2 now here? T2 का steps बोलो. That is, so here 1, 4, 2, 3, 1, 4, 2, 3. So what I will get now here? This is K bar into Q plus 2 3 means J bar into Q bar, and if I multiply this value, this is plus J Q bar plus 0. So what I will get to tell me now? Q plus, that is J Q bar plus K bar into Q. This is the equations. So this is the JK flip top कैरेक्टरिस्टिक इक्वेशन ना, हमको ये सेम आया कि नहीं ये ऑप्शन से, सो दिस ऑप्शन इज करेक्ट. ऐसा वेरिफिकेशन से करना पड़ेगा, सो थोड़ा ज़्यादा टाइम लगेगा, बट लेकिन दिस इज द ऑप्शन. अदरवाइज आपने पूरा टेबल फॉर्म में दिया ना, वो स्मरण करना पड़ेगा. राइट, यू कैन सी दिस थिंग. If the input to a toggle mode T flip-flop is a 100 MHz signal, the final output of the 3 flip-flop is cascaded is. So this is final output frequency they are asking. So that means frequency of the output, which is given as, what I can say, this is f clock by mod number, which is given as, what I can say, f clock by mod number. So how much this f clock, you see, how much this f clock is given as a 100 mega, given 100 megahertz by, so this mod number is what you tell me now here. So they given a toggle mode final output of the 3 cascaded, which is nothing but, what, tell me, 8 now 3 flip flops are cascaded 0 to 7 mod 8. So how much will get now from this 8, that is 12.5 something will come now, 12.5 like that will come, 0.5 mega. Next one, 5 JK flip-flops are cascaded to form the circuit shown in figure. Clock pulses at a frequency of 1 mega are applied as shown. The frequency of the waveform at Q3 is. First of all, you can see this is what type of counter, you tell me now here, synchronous or asynchronous, you tell me. So this is asynchronous counter. Alag alag clocks na. So this is the external clock is given. This is the LSB, and this is final. This is a MSB. And you can see now here they given this as F clock is given here. Here this output is, what, tell me now, f clock by 2, and second one output is f clock by 4, and this here this output is f clock by 8, and here this is f clock by 16. So tell me now here output Q3, which is given as, what I can say, f clock by 16, that is 1 mega. That means I can say 1000 into 10 cube by, what, tell me now, mega. So this is, which is a 16. So tell me how much will get 1000 by 16, which I will get it as into kilos we are converting, that is 62.5 K. You can check this value. They ask in terms of kilohertz. So enter the value 62.5 kilohertz. Next, a 3-bit triple counter is constructed using 3 T flip-flops to do the binary counting. The 3 flip-flops have inputs are, so We need to construct what I mean. Ripple counter means asynchronous counter. Asynchronous counters means all the flip flops must be operated in कौन सा मोड में ऑपरेट करना पड़ेगा, टॉगल मोड में ऑपरेट करना पड़ेगा. टॉगल मोड करने के लिए टी फ्लिप फ्लॉप में टी वैल्यू मस्ट बी गिवन. व्हाट टेल मी, 0 or 1. All the t values must be given as 1. If t is equal to 1, then only the t flip flop will behave as a toggle mode. So that t must be 1. Next, two D flip-flops are constructed as a synchronous counter that goes through the following QB QA sequence. The connections to the inputs DA and DB are and you can see here. Now you can see now here the, let us form the some tabular form. Here this is the sequence required. We need to go for the designing. We have to do it now. Present state and the next state and flip-flop input. So remember the tabular form we used to form. Now we need to find the designing karna padega. Present state, so which we have taken this as a QB and QA. The next state is what we can say, tell me now, QB plus and QA plus. And what flip-flops are now here? D flip-flop, that is DB and this is DA. Now initial state, this is the pattern given. Initial state, if it is 0 0, the next state for this is what, tell me, 1 1. If 1 1 is a present state, if 1 1 is a present state, and what the next state for this, you tell me, 0 1 is a next state. If 0 1 is a present state, 0 1 is a present state, and what the next state, you tell me now here, 1 0 is a next state. If 1 0 is a next state and present state, 0 0 is a next state. This is the pattern we should form it. And you can see now D flip flop output, we know Q plus is equal to D only now. Whenever the output is 1, the D must be 1. So this is 1 0 1 0. So 1 1 0 0. So you can see now here this is now D. So what is the DA value, DB value we have to see. So these are the min terms. So tell me now here which is given as, this is my QB bar, this is QA bar, plus what I can say, tell me next one, this is QB and this is QA, which is nothing but X naught na. Next, what about the DB value, tell me, DB, these are the min terms. So you can see now here this is QB bar and this is QA bar plus QB bar plus QA. So which I will get, QB bar common. So QA bar plus QA, which is equal to 1. So that means DB is equal to QB bar. And so कौन सा option you see this thing? D option. Done. Chalo, next problem. Now a synchronous counter using two JK flip-flops that goes through the sequence of the states given like this. This is a sequence required. To achieve this sequence, the inputs of the flip-flops are, here also this thing same as earlier, we need to form it. We need to form the tabular form, we need to form it, and form the tabular form. Here you can see now the sequence will be given as what they given. We need to form the sequence form. It is what type of counter here? Is a synchronous counter now here. Same clock is given. So synchronous counter. So let us form the tabular form here also. We need to find out this is sequence. We need to do it now here. Now tell me the present state first of all. Present state, next state and flip-flop inputs. Flip-flop inputs, what we have, tell me now here. J1, K1, this is one flip-flop, and this is J2 and K2, this is the another flip-flop. Right, so this is the flip-flop inputs. The flip-flop inputs, we have to do it. Now you can see now initially, and you can see now present state is given as what, tell me, 0 0. Present state is given as 0 0. So this is what we can say now here. This is Q1 and Q2, and this is Q1 plus and Q2 plus. The next state is 1 0. 1 0 is a present state. Next state is 0 1. 0 1 is a present state. Next state is 1 1. 1 1 is a present state. Next state is 0 0. Now we should recollect the JK flip-flop excitation table. So tell me now, recollect the JK flip-flop excitation table. That is what we can say now here, Q plus, which is what we can say Q plus, and which is given as, and then what, tell me now here, JK 0 0 0 1 1 0 1 1. You can tell me now 0 0. So this is 0 cross, this is 1 cross, yes, cross 1 and cross 0. Now you can see this thing here. So 0 1, 0 1 means what we can say now here, 1 cross 1 0 1 0. 1 0 means what we can say now, cross 1. 0 1, 0 1 means what we can say, 1 cross 1 0. 1 0 means what I can say, cross 1. All of you. And you can see now here J2 here. 0 0 means what we can say, ox. 0 1, 0 1 means 1 cross 1 1, 1 1 means ulta ox. 1 0, 1 0 means what we can say now, cross 1. ऐसा हो गया. Now we need to get the J. So all J's are there. So means J is equal to 1, I can say. So from this, J1 is equal to 1, K1 is equal to 1. All are 1s. Next we can see now J2 is equal to, we have only one minterm. Tell me now J2 minterms. So here J2 case, this is only the one minterm now here. Right. And you can see now this option here, J1 K1 is equal to 1 1. J1 is 1, K1 is 1. This is only the option you can say directly, we can go for this thing. So instead of going for all thing, we can verify this thing. That options we can eliminate now. Remaining all options, right? Next one. The next state, table of a 2-bit saturating up counter is given like this. The counter is built as a synchronous sequential circuit. The T flip-flop, the expression for T1 and T0 are. Okay. So we should design it now. T flip-flop designing also easy. This is output is simply XR only, na? The characteristic equation we can easily remember for T flip-flop also. Now tell me now flip-flop inputs they given present state, next state is already given. So what I can say, this is my T1 and this we can call this as a T0. Tell me 0 0. So which is a 0? 0 1 which is 1 1 1, so this is 0 1 1 which is a 0 0 1 which is 1 1 1 1 0 1 0 1 is 1 1 1 which is a 0, isn't it? Tell me all of you. Now you can tell me now T1 is what? Tell me T1, it has only one minterm here. This is the minterm now here, which is given us what you can see now here, Q1 bar and Q0. Next T0, T0 is given us what we can say here, this is what a max term now. Max term is what we can say, tell me now here. So this is Q1, yes, Q1 plus Q0, Q1 plus, so Q1, yeah, Q1 bar plus, sorry, Q1 bar plus Q0 bar now. कौन सा option? Option D. Check it everybody. Read. Then you try to solve the problems. If you have any doubt, you can ask me. If you have any doubt, you can ask me. Okay, so some problems I think may not be covered, I think so. Okay, I think so majority of the problems I covered. I think so what are the problems? The problems I solved, those are the tough questions might be, and easy questions I left, I think so. ECE के लिए I think I might not done any practice session revision course. Revision course, you check the one else revision course now. The fast track course, you check the fast track course on digital. There I might be solve the problems. You can check in my profile, fast track course or revision course, RIB course, maybe I have given these names. You can check there may be possible, I think so. You may get there. Right. So this is the way we can solve these problems. Right. And the next class will continue the remaining problem. The same manner will continue and will do problems. Okay. Right. Yeah, that's for the today's session and we'll meet in the next class. Okay then, see you, bye bye, good night.